Now let's speak about hydrogen and oxygen forming water and the difference between actual amounts and ratios here. So in this picture we can see the actual amount of hydrogen molecules is 1, 2, 3, 4, 5, 6 hydrogen molecules, which is 12 hydrogen atoms. Those are actual amounts that we have here. In a real experiment, you will never isolate such a little bit, because that's really, really tiny. You would not even be able to detect so little hydrogen. But we can't draw pictures for the reasonable amounts of hydrogen that you really work with. So that's why I'm just simplifying things here to fit with the pictures. So here we have 6 hydrogen molecules and we have 3 O2 oxygen molecules, which is 6 O atoms. And they react together to form 1, 2, 3, 4, 5, 6 water molecules. We're not really interested in the numbers of individual atoms usually. So let's just write it like this, referring to the molecules, because molecules exist stably. They can exist on their own without reacting necessarily with something. They can react with something, but not necessarily have to. Now let's speak about ratios. To get the ratio, we just write this particular actual amount or any other possible actual amount in its simplest format, its simplest relationship. In this case, divide through everything by 3, which gives us 2 hydrogen molecules for every 1 oxygen molecule for every 2 water molecules produced. That's the particle ratio, and then we can also work out a mass ratio. So here we have the particle ratio, 2 hydrogen molecules for every 1 oxygen molecule for every 2 water molecules produced. Now remember that these numbers here can refer to molar mass or relative atomic mass. And here we're counting just a few molecules, so we are going to measure their mass in atomic mass units, AMU. So 2 hydrogen molecules would have a mass of 2 times 2 times 1 atomic mass units. Why? The relative atomic mass of H2, hydrogen, is 2 times 1 atomic mass unit per atom, which is 2 atomic mass units for every 1 hydrogen molecule. But here we have 2 such molecules, so that's why it's 2 times this. 4 atomic mass units is the mass of these 4 atoms of hydrogen, in other words, the 2 molecules of hydrogen. And 1 oxygen molecule would have a mass of 1 times 2 times 16 atomic mass units, because this one has a mass of 16 atomic mass units and this one 16. So the 2 together have a mass of 32 atomic mass units. The 2 water molecules would have a mass of 2 times 18 atomic mass units. Why 18? We can see from here, 2 times 1 atomic mass unit per molecule for the hydrogen plus 1 times 16 atomic mass units for the oxygen makes 18 atomic mass units for every molecule. And here we have 2 molecules, so that's 2 times 18 atomic mass units, which is 36 atomic mass units. And again, notice how we haven't created or destroyed matter. So at the start, the mass is 4 plus 32, which is 36 atomic mass units, and at the end it's still 36 atomic mass units once they've reacted. Matter hasn't been created or destroyed. So these ratios are equivalent amounts. They all refer to this particular reaction of hydrogen reacting with oxygen to form water. So we can use these ratios to solve problems. How many hydrogen molecules? Now we can't just write how many H2, because H2 means a molecule. There's no such thing as an H2 atom. If it's H2, it is molecules. Are needed for 5 oxygen molecules to react to form water. Again, we don't need to write molecules because O2 is a molecule. That tells us we're speaking about molecules. So that's the question. We must now multiply it by a conversion factor, which has oxygen molecules at the bottom, not grams of oxygen molecules, just oxygen molecules, or not AMU of oxygen molecules, just oxygen molecules, and hydrogen molecules at the top. And we know that 2 hydrogen molecules react with every 1 oxygen molecule in this particular reaction, in other words, to form water. Cancel away oxygen molecules. 5 times 2 is 10 hydrogen molecules. And obviously, if we have 5 oxygen molecules, we need to have 10 hydrogen molecules to react with them, because always you need double as many hydrogen as what you have oxygen for this particular reaction to form water. How many oxygen molecules react with 20 atomic mass units of hydrogen? We need to multiply this by a conversion factor, which has atomic mass units of hydrogen at the bottom to cancel that away, and oxygen molecules at the top to introduce the required unit. And these two, the top and the bottom, must refer to this particular reaction, the ratios of reacting for this particular reaction. And we know that one oxygen molecule reacts with 4 atomic mass units of hydrogen. 20 divided by 4 is 5 oxygen molecules. We can also see that by 20 atomic mass units of hydrogen means that we have 10 hydrogen molecules, because each hydrogen molecule has a mass of 2 or more. And we know that we need double as many hydrogen molecules as oxygen. So if we have 10 hydrogen molecules, we'll need 5 oxygen molecules.